Hello, so this is the lesson on gases 5.5. There are a few things you need to know about gases. The first one is that gas particles, like you see here, experience very little attractive forces. So we're going to ignore the fact that gases experience London dispersion forces or other intermolecular forces. We should know that gases are easily compressible. You guys could easily compress these gas particles inside balloons. You could put them in aluminum cans. You could compress them in spray cans. You could compress them into gas tanks. So they're easily compressible. Gases do have a mass, but the mass is very small. You should also know that compared to the other three states of matter, gases tend to move the fastest and they have the most kinetic energy. More kinetic energy means there's more movement, and more movement generates a higher temperature. So as you add heat, the particles start to move faster and faster, and because of this, they experience a higher temperature. The next thing about gases is you should know that because they're constantly moving at high kinetic energies, they're going to have a large distance between them. And you should also know that whenever gas particles whenever they hit the walls of a container, it generates pressure. So the more collisions there are, the higher the pressure of that is exerted on the object. Unlike solids and liquids, gases completely fill their containers because they're constantly moving all over the place. So we say that the volume of the container is the volume of the gas because the gas particles are moving all over the place. Gases have high kinetic energies, and high kinetic energy is defined as the energy due to motion. So the more something moves, the higher the kinetic energy. So gases, for example, have a higher kinetic energy than liquids, and liquids have a higher kinetic energy than solids, for example. Gases are typically measured in Kelvin, and we're going to learn a little bit more about Kelvin in a bit. But usually when we talk about gases, we always use Kelvin as the unit. Okay, Kelvin is usually used as the unit of temperature. And temperature, you guys probably think, oh, what is temperature? Temperature is how hot or cold something is. That's true, but in chemistry, temperature is actually measured as the average kinetic energy of particles in an object. So when we talk about temperature, we're actually talking about how fast the molecules are moving. So the faster the molecules move, the higher the temperature. The less the molecules move, the lower the temperature. So temperature is a measurement of how fast the molecules are moving, the particles are moving in a container, and it's the average of the kinetic energies. Okay, so you should know that. The next thing you should know about gases, let me just erase this. Again, if I'm moving too fast, you guys could read through the slides. It's pretty straightforward. Maybe the only one that's not straightforward is number 8, but it's something you guys can memorize. We already talked about this. Something you need to know about kinetic molecular theory, KMT, which stands for kinetic molecular kinetic molecular theory. Why is this pen not working? Molecular theory. Kinetic means movement, molecule means molecules are involved, and the theory is this idea that particles are moving randomly. We cannot predict the direction of where they're moving. However, because they're constantly moving everywhere, every time they hit the container, the walls of the container, it's going to generate something called pressure. So the higher the temperature means the higher the kinetic energy. of the particles, and the higher the kinetic energy of the particles means there's more movement, and because there's more movement, there's going to be more pressure because there's more collisions with the container itself. So that's another main idea from this slide. You guys should know that kinetic energy is directly proportional to temperature. So the higher the kinetic energy, the higher the temperature. We say that this is directly proportional. Directly proportional means that when one thing goes up, the other thing goes up, or when two things go down at the same time. So that's that slide. Let me erase all of this. And when something's directly proportional, you tend to see a straight line. It's probably not a good example of a straight line. Why do we use Kelvin? We use Kelvin because we wanted to create a temperature where 0 is the lowest temperature that could exist. So the lowest temperature that could exist in Celsius is negative 273. That's the lowest that could exist. However, having a negative temperature didn't make sense to a chemist, because if a gas is at, let's say, negative 10, it's still moving. If it's at negative 100, it's still moving. So chemists wanted to come up with a temperature where 0 is defined as 0 molecular motion. So that's exactly what they did. They created the Kelvin right here in green, where 0 Kelvin is the temperature at which all molecular motion stops. And because of that, the Kelvin was created, and that is why we use Kelvin when we talk about gases, because gases tend to have a very, very low temperature. Because gases tend to evaporate at relatively small temperatures. Now, I taught you guys this first semester, but you guys probably forgot, and that's okay. We're revisiting it again. If you want to convert something from Celsius to Kelvin, you have to add 273. If you want to convert from Kelvin back to Celsius for some reason, such as canceling units or whatever, maybe they want the answer in Celsius, then you would subtract 273 from Kelvin. So anytime you want Kelvin, you add. Anytime you want Celsius, you subtract. Okay, this magic number of 273. So I'm going to do the first example, and you guys will do the 2, 3, and 4 on your own, and check your answers to make sure you're doing it correctly. So the first one says convert room temperature, which is 20 degrees Celsius, to Kelvin. So I want Kelvin, so I want to add 273. So I'm going to plug this in here. So 20 degrees Celsius plus 273 is equal to 293 Kelvin. We don't put degrees here. This would be your answer. So go ahead and try 2, 3, and 4. Go ahead and pause, try, and then check your answers, okay? So your answers to 2 should be 0 degrees Celsius plus 273. We want Kelvin, so you're going to add. So that's 273 Kelvin. 3, 254 Kelvin. And you want it in Celsius, so you're going to have to subtract in this case, and you're going to get a negative number, negative 19 degrees Celsius. And for number 4, you should add 273 because you want Kelvin, and you're going to get 313 Kelvin. Okay, so those are your answers to the 4 problems. Hopefully you guys got those right. Okay, so now we're going to go on to the next slide. Okay, so the next slide just talks about different units of pressure. There's a bunch of different units for pressure. The most common one is called the atmosphere. 1 atmosphere is standard. So this is standard pressure. So standard means that it's very common. It's the pressure at sea level. So if you're at sea level, you're gonna have um, uh, you're gonna have 1 atmosphere um, exerted on you. However, sometimes chemists use the torr, and 1 atmosphere is equal to 760 torr, or 1 atmosphere is equal to 760 millimeters of mercury. Millimeters of mercury is another unit used in thermometers because thermometers have mercury in them, or they used to, the old school ones. 1 atmosphere is also equal to 101 kilopascals, which is equal to 101,000 pascals. And you should know that standard pressure is 1 atmosphere. So these are just different units. Don't get scared. They're just different units. You guys don't have to memorize them, but for some reason they end up sticking into your brains. Something that you do have to memorize is what STP is. So standard temperature and pressure. Standard temperature and pressure. So standard temperature means the most common temperature. And we say in chemistry that standard temperature is defined as 0 degrees Celsius or 273 Kelvin. Okay, so don't get confused. It's not 0 Kelvin, it's 0 Celsius. So absolute 0, don't get confused. Absolute 0 is 0 Kelvin. And standard temperature is 0 Celsius. Okay, very, very different. And standard pressure, which you just learned, is 1 atmosphere. Okay, so there's that. And that's where I'm going to end this podcast.